Um, Hi sir, hi ma'am. This is Agam Arora of Section B. My registration number is 2427030009, and the processor I was assigned with was Intel 8051. So let me open my PPT. This is my PPT. The processor is Intel 8051. So let's start. So this processor was introduced in 1980 as a 8-bit microcontroller, and it belongs to the complex instruction set computer architecture family. It was mainly designed for the embedded systems, and it has CPU ports. Every port, serial port, is on one chip only. This was the architecture overview. On to the next slide. Its main features are 8-bit. It has a 8-bit CPU. It has a 8-bit data bus and also a 16-bit address bus. Also, it has a Harvard architecture which has a separate program and data memory. It consumes very less power as it was very, introduced in 1980. So its instruction set architecture is as follows. It has many modes like intermediate, which in which the value is directly assigned to the instruction, and the direct mode in which the value is assigned to the memory address. In register mode, the data moves between the registers, and the indirect mode in which the data is moved to the address of the register. So the next slide is data path and pipelining. Uh, It has many features like ALU. It performs the operations. Accumulator is used in every instruction, and the one B register is used for many like dividing, multiplying, as we will use in our program uh, after some time. It also has a program counter to move to the next instruction. So stack pointer, which uses the principle of stack, which we have already learned in our classes. Now on to the memory hierarchy. The memory hierarchy is divided into like three parts. It has a 128 bytes of memory, in which 32 bytes is assigned to the register bank, and 16 byte is for bit addressable, and the rest is for general purpose RAM. Also, it doesn't have any cache memory. All the memory access are direct. And as I told you before, the Harvard architecture, it has a Harvard architecture which has separate buses for data and program and memory. Uh, Also, there are many special features like it supports bit level operations, like operations which can clear everything from one instruction. Also, it has an interrupt system, very small which. Also, it has many timers and counters. Also, it has a serial port built in its that system. Um, That's it. It has a great historical significance because it was one of the few chips that had embedded systems, and it started the era of embedded systems. Also, it has been licensed widely to many companies like Atmel, Philips, NXP, Siemens, and also I have used this NXP in my project, which I will show you. Uh, Now that's it. Now I will show you my simulation code, which is of the finding the factorial. Um, So now it's time for simulation demo, and my simulator is Keely Vision. So let's open it. It will take some time. Okay, is it? Let me explain you the code briefly. So in R naught register, we are storing the value. We are storing the value of the number we have to find the factorial of. And in R1 register, we are, initializing the factorial result to 1 so that when we, move the loop, iterate the loop, it will be easier to us, it will be easier for us to calculate the result. So I'll press F7 to see if there are any errors or not. So as you can see, here are zero errors or zero warnings. So we can continue to run the code. So I'll start. So now I'll explain you the code by step by line by line. So we are storing the value 5 in our R naught, and we are storing when 1 in R1 as a result. Now let me tell in this. So in this loop, we are, storing the result of R1 into A and the value of R naught into B. And in the next line, we are multiplying these both values. So currently it's 5 into 1. Then we are moving the result that AB again into R1 and then decreasing in the next line we are decreasing the value of R0. So R0 was 5, now it's 4. Now in the next loop we are doing the same thing and then we are multiplying again. So it's now, yeah, as you can see, it's 14 and 14 is 20 in decimal terms. So in the next loop, now as you can see, it's different. Now it's 60. And the next loop, it's 78. 78 is 120 in, decimal terms. And now we'll run the last loop. Last loop, it's again 78 because we're multiplying the result by 1 and it will remain the same. So that was it. And yes, that was it. Thank you.